Okay, so here what we're going to be doing is we're going to be looking to find a function given we know a differential, given we know a gradient. So because we know a gradient, we know we're looking at integration. Okay? Because I know the gradient, if I integrate that with respect to x, I get f of x. Okay? So what I'm going to do is I'm going to integrate it, e to the x plus, I'm going to write this slightly differently, 1 over root x is x to the minus half. Okay? So we're going to integrate this as such. Integral of e to the x is e to the x. Integral of x to the minus half, we add 1 to the power and then divide, so it will become that. Now that's not everything. When you integrate, you also get a constant. And if you think about it, it kind of makes sense, because if I differentiate this, I get e to the x. If I differentiate this, I would get x to the minus half, or 1 over root x. If I differentiate my constant, it would disappear. Therefore, any time you do an integral, you have to remember the constant function. So at the moment we have this. And what I'm going to do is I'm going to use my boundary value, the given value here, I'm going to substitute that in. If I put that in, that will allow me to determine what c must be. So f of 1, okay, I'm going to replace all the x values with 1, is e plus 2 plus c. And I know that's got to be equal 1. So in this case, c is minus 1 minus e. Okay? And that allows me to finally write out f of x again. E to the x, 2x to the half, and all I'm going to do is I'm going to replace c with my value, minus 1 minus e.